I, at any rate, do not believe God plays dice with the universe. Albert, stop telling God what to do. This series of presentations centers around an event in 1964, which, incidentally, is also the year of my birth. 58 years later, on October 4th, 2022, 3 Nobel Prizes were awarded for proving experimentally what John Stewart Bell proved mathematically in 1964. Why is that important? Because it shatters 300 years of conventional wisdom that began with Galileo and more formally with Isaac Newton and Pierre Laplace. This discovery has been known for quite a while, but not widely understood, even among physicists. So, I decided to produce this series of presentations to quickly bring audiences up to speed on the profound significance of what is arguably the greatest discovery in science history. Bell's theorem was already 7 years old when John Clauser devised the first experimental test. Alan Aspect would perform a more sophisticated test between 1982 and 83. By 1990, Bell would be nominated for a Nobel Prize. He died of a cerebral hemorrhage before ever knowing he was being recognized for the most important discovery in the history of science. But Nobels are not awarded posthumously. So, the world outside of theoretical physics was denied knowledge of his discovery. In fact, the issue was largely controversial, and anyone wanting to tackle the issue was almost universally discouraged from doing so on the basis that even Bohr and Einstein couldn't agree. Most physicists chose a more agnostic position and considered the issue metaphysical. Through the 1990s and beyond, Anton Zeilinger was working on practical applications in quantum computing, and the eventual realization that Bell's work had practical applications is why all 3 men shared the Nobel Prize for Physics in 2022. In a nutshell, John Stewart Bell proved the impossible, and it only took the world outside of physics 58 years to find out. You may also be surprised to find out that Bell was not satisfied that his own discovery was revolutionary, which is also true of the scientists who developed quantum mechanics in the first place. Historical mile markers are few and far between. Sometimes centuries pass before the uncommon sense of some anonymous genius becomes common sense for the rest of us, and that is exactly the destiny of Bell's discovery. In Part 1, we will begin at the beginning, so to speak. We will take a bird's eye view of the history of philosophy and the big questions that have puzzled the world's greatest minds for more than 2,500 years. In Part 2, we will quickly bypass centuries of scientific stagnation and come to the beginnings of modern scientific thinking in the 17th century, when Isaac Newton, Christian Huygens, and others begin to express interest in optics and the nature of light. It was also a period of social and political enlightenment, and so it seems we can speak of enlightenment both figuratively and literally. In Part 3, we will talk a bit about the early science of thermodynamics in the 19th century, the black body problem, and what would later be known as the ultraviolet catastrophe, which would eventually lead to the quantum revolution. In Part 4, we will focus on what George Gamow called the 30 years that shook physics. Here, we will examine the flurry of discoveries made by numerous Nobel laureates from Max Planck's constant in 1900 to the formal convening of the Fifth Solvay Conference. This part is retrospective of the Age of Enlightenment, where long-standing mysteries about energy and matter are finally unified with the development of lasers and studies in the nature of photons and electrons. In Part 5, we will discuss the events following the Solvay Conference, including the great debate between Einstein and Bohr, which led to Bell's discovery. And then we will step ankle deep into the future of science. So let's get started. I'll see you in part 1.